So, at the end of last video, we started chapter 5 talking about, because chapter 5 focuses on the membrane, the plasma membrane, and focus on the fluid mosaic model, this mosaic of different molecules that is composed or composes the plasma membrane. So, some terms here to be aware of. That membrane is what we call a selectively permeable membrane. It's only going to allow some material to come through, some material to pass, and it's going to deny others. And a lot of times that has to do with their polarity. And so but it also has to do with their charge. So some of those molecules will get bound up within the phospholipid barrier, depending on their polarity and depending on whether they have an ionic charge or not. We talked about diffusion. And diffusion is natural spreading out, if you will, of molecules from a higher location of higher concentration to lower. And that's driven by a gradient. A gradient is where you have a difference in concentrations. Equilibrium is when you have no gradient. There's no difference in concentrations across. And osmosis is the diffusion of water to try to move to areas of higher concentration of solutes to dilute them out. We mentioned passive transport versus active transport. And then there's a couple of ways our cells normally will do facilitated transport using proteins to move molecules past the selectively permeable barrier. Didn't spend a lot of time on active transport. I think that's appropriate for a general biology class to not spend too long there. Just be aware that there's the idea of active transport, and that generally consumes cellular energy. It consumes ATP in order for that to happen. And I think that'll be appropriate for what we're doing. There's some really good stuff in the chapter about the sodium and potassium gradient. And while that's important, I think we have enough stuff here to talk about. So if you want to read more about it, please do. And it's going to be helpful for you, but I just didn't think it was critical for us. But we do need to be aware of what is osmosis, how is it driven, what controls it. If I put cells in a solution that has a different concentration within the solution versus the concentration of those solutes within the cell, that's going to regulate the diffusion, the osmosis of water. We call those solutions described by the direction which water is going to flow. It really refers to as the concentration higher or lower in the solution. So hypertonic means there's more solutes in the solution than in the cell, meaning water is going to leave the cell to try to dilute the solution. So that's what a hypertonic solution will shrink cells down normally, as opposed to hypotonic means the solution, the concentration of solutes is higher inside the cells, so the water will try to get into the cells to the point sometimes where they'll burst if the cells can't handle the water intake. Isotonic means there's an equilibrium. There's as much water entering as there is leaving. Okay, what else we got here? Oh, just real quickly here. I'm literally getting the text message and the phone call that we are closed tomorrow right now as we speak. Anyway, I just grabbed these two videos. I've told you guys to watch these videos before. I thought I'll just throw these at the end of this last video, so you've got them one more time, because the second video is really good review for chapter 4. The first one explains why chapter 3 and 4 are so important when they work together. I hope you find them interesting. I did. I enjoyed them. I'm sure you can find more, but I know everybody's time's valuable. But hey, maybe you're sitting at home with nothing to do because you're stuck and you can't get out right now. So here's a couple of YouTube videos I thought would be really helpful for you. Okay. I'm going to stop there. If you guys have questions for me, let me know. We'll go from there. I will be in Zoom here in a little bit. I've got to get these videos uploaded to YouTube and update the page. But I'll see you guys soon if you need to stop by and ask questions.